All right, guys, this is going to be the second video here on sampling distributions. We're going to be looking at two main types of sampling distributions, one on proportions, one on means. And just as a reminder from the last video, sampling distribution, basically the idea is that, okay, well, if I look at our AP Stats classroom, for example, I take a sample of 10 different people, find their average height. Each time I take a different sample of 10, I'm most likely going to get a different set of 10 people. And so each time I calculate the average, it's going to be slightly different every time. And so basically, if you take all those averages, you can kind of put them on a number line and make a distribution. And that distribution kind of makes up your sampling distribution, right? And the thing with the sampling distribution is that it has to be all possible combinations of 10, right? So we talked about combinations in the last unit. This guy where it comes back. And so for a true sampling distribution, you need to have all possible combinations of 10 in that example. So there's a little app that I'm going to show you guys in class. So I'm going to skip these first two pages. It's pretty interesting to take a look at. And you kind of just look at what happens as you take bigger and bigger sample sizes. What happens to the distribution? So that's pretty interesting. Okay, so look at a couple things here. And again, the last page 53 of these notes, we will do that in class together. So first question is, when is it okay to say that a distribution is approximately normal? And we're going to say that a distribution is normal when you have this thing called the large counts condition. And here, this is n times p needs to be greater than or equal to 10. And n times 1 minus p needs to also be greater than or equal to 10, right? And here, you need to check both. Okay. So you can't just check one or the other, you got to check both. If they're both larger than 10, you can say that the sample is approximately normal. So then, how do you calculate the mean of your sample, and how do you calculate the standard deviation? Well, last time we talked about unbiased estimators, and if we know that our distribution is approximately normal, we're going to have an unbiased estimator. And so what we can say is that p hat, okay, and the hat represents the sample, okay. So regular p would be for population, p hat represents sample. This is equal to, I can just rewrite this as the mean p hat, which is the same thing as just p, okay, because it's an unbiased estimator. Your standard deviation of p hat, so we're going to denote it, is equal to the square root of p times 1 minus p over n. Okay. And I want you to think about this equation a little bit, right? Think about this. As n gets larger, what's going to happen to this fraction, right? And this kind of goes back into the whole, it's going to answer some of the stuff on the previous question as to why we check these large counts. Because as n gets larger, this fraction is going to get smaller and smaller, and therefore you're going to have less variability, right? So as your sample size increases, you're going to get more and more, or less and less variability. So that's kind of where that comes from. And again, still need to check that n is less than or equal to 1/10 of capital N, right? That's the independence condition that we've talked about before. So make sure we're checking these conditions. This last problem, I want to talk about the state plan do conclude. We've kind of talked about it before, but this is something I want to spend quite a bit of time on in class. But I want you to read it, see if you can figure out the mean and the standard deviation, and see if you can interpret it, and see if you can calculate and find this probability. And then I'm going to talk about the state plan to conclude, the 4 steps that we're going to be using for a lot of these problems as we go along. So we'll talk about that in class. We'll spend some time on it, see if you guys have questions. But that's basically it for the 7.2 video. So if you guys have questions, let me know. In the next video, we'll look at distributions for the mean.